Hello and welcome to Algorithm Integrity Matters. Insights for financial services leaders who want to enhance fairness and accuracy in their use of data, algorithms, and AI. I'm your host, Yusuf Mullah. This article was published at the end of October 2024. It's titled Risk-Focused Principles for Change Control in Algorithmic Systems. The background to this article is that there are several change control procedures from traditional practices around financial audit and audits of information systems. But change in algorithmic systems is quite different. And so we do need to reconsider what we want to focus on when we designing, implementing, auditing change control practices as they relate to algorithmic systems. And so this article explains that difference and then a risk-focused, principles-based approach to change control to ensure that the set of controls that you use properly address the risk and are effective and efficient. So here we go. With algorithmic systems, a single uncontrolled change can trigger a cascade of unintended consequences, potentially compromising fairness, accountability, and public trust. So managing changes is important. This is a given. But with algorithmic systems, change control goes beyond traditional practices. While the base concepts may be similar, the specific risks differ. Importantly, if you use the wrong framework, you could be including controls that you don't need, excluding controls that you do need, and not really addressing the risk. Your change control process may then tick the boxes, but be both ineffective and inefficient. This article outlines a potential solution, a risk-focused, principles-based approach to change control for algorithmic systems. An existing guideline. There are well-established methodologies and guides for change control. We'd ignore them at our peril. We can learn from them. For example, one source is from financial auditing, often cited in establishing algorithm audit methods. The ISA 315 guideline for general IT controls includes 4 key elements of change management. Number 1, change management process. Ensure changes are properly planned, tested, and implemented. Number 2, segregation of duties for change migration to prevent unauthorized changes from being implemented. Number 3, system development, acquisition, or implementation to ensure new systems are properly designed and tested before deployment. 4, data conversion. Maintain data integrity during system changes or upgrades. Traditional IT change control versus algorithmic systems change control. The typical objective of IT change control is to minimize fraud and error. This holds true for algorithmic systems, but it's not just about keeping systems running smoothly and accurately. We also need to establish trust, fairness, confidentiality, and accountability. This means that when we audit change control for algorithmic systems, we maintain a level of focus on error and fraud, but also pay attention to other risks. The ISA guideline focuses on financial statement risk. It is mainly about fraud and error. It's a solid base, but it won't fully address the unique risks and challenges posed by algorithmic systems. For example, complexity. Many AI and machine learning models are complex, making it difficult to predict the full impact of changes using traditional testing methods. Data dependency. Changes in input data can significantly alter algorithmic outcomes without any code modifications, a scenario not always directly addressed in traditional IT change management. Ethical implications. Financial statement audits rarely consider the ethical implications of changes, which are crucial for AI systems making high-stakes decisions. Confidentiality. The data must be kept private, and often the algorithms contain IP that must not be leaked. So we need to expand and/or adapt to cover the unique needs of algorithmic systems. Key aspects of change management for algorithmic integrity. Drawing on the ISA 315 guideline and expanding to encompass algorithmic system risks, here is what the 4 key controls could translate to. Number 1, robust design and testing processes. Before any change is implemented, it must undergo rigorous design and testing, including impact analysis, how the change might affect the algorithm's accuracy, fairness, and alignment with business objectives, comprehensive testing, so using diverse datasets to ensure the change performs as expected across various scenarios, and then peer review. The proposed changes are reviewed by other data scientists or AI experts to catch potential issues. The second control would be controlled migration to production. The process of moving changes from development to production environments must be tightly controlled, including segregation of duties. Staging environments, so an environment that mimics production for final checks before go live. Rollback plans, clear procedures for reverting changes if unexpected issues arise. Segregation of duties, so clear separation between those who develop changes and those who implement them in production, limiting access to make changes to production algorithms. And then approvals, multi-step approvals for changes involving both technical and business stakeholders. The third, documentation and auditability. So every change must be meticulously documented, including change logs, so keep detailed records of what was changed, why, and by whom. Version control to track changes over time, and audit trails. All actions are logged and traceable. Then the fourth one is data integrity. So changes in input data continue to support the business objectives, including data quality. The data continues to be correct and fit for use. Data approval, a formal process for approving new or revised data sources for use in the system. And then data lineage and provenance, documentation to explain and track data flows, including transformations from sources to targets. This could be a good starting point, but not all systems are the same. Tailoring the change control approach. The approach to controlling change will vary, depending on the nature of the system, the level of complexity, whether the system is developed in-house or is purchased, and the risk management focus. Here are some examples. They are hypothetical, but based on real-world observations. And just a note, when I talk about risk focus, it's not exhaustive. It would be based on a risk assessment and is purely indicative. Example A, credit scoring systems. In this case, we're thinking rules-based, in-house developed. So the risk focus may be transparency and regulatory compliance. And then in the article, there's a set of potential key change controls under that. Example B, insurance pricing models. So this could be machine learning and purchased. The risk focus here may be performance, fairness, and model interpretability. Example C, AI-powered insurance claims processing, in-house developed. And it said AI-powered, so it's machine learning and things. The risk focus may be efficiency, accuracy, and fraud detection. And then example D, credit limit assignment system. Here we may have a hybrid rules and ML type system, in-house developed with third-party components. The risk focus here, fairness, accuracy, and explainability. Again, the risk focus is not exhaustive, it's just purely indicative. So in short, not all systems are the same, as depicted in the simple hypothetical examples I just gave there. So rather than a standard set of controls, it may be better to start with a risk assessment, then use a set of principles to guide control selection and design. So let's talk about that, risk assessment and principles. Truly effective change management for algorithmic systems must align with broader principles of algorithm integrity. By overlaying the traditional change control guidelines on the 10 key aspects of algorithm integrity we've previously discussed, we can craft a set of guiding principles. This approach allows us to adapt specific change controls based on risk assessments, with the principles then steering the implementation details. So let's start with the overarching focus on a risk assessment. The risk assessment process should identify potential risks across all areas, so including things like performance, fairness, transparency, security. Prioritize risks based on their potential impact and likelihood. Guide the allocation of resources and focus areas. Be regularly updated to reflect evolving threats, technologies, and regulatory landscapes. That sets the foundation. Principles. With our risk-based foundation in place, we can use these principles to develop our controls. The first one, changes enhance the algorithm's accuracy and robustness. And the risk link here is performance degradation and errors. Principle 2, changes enhance or maintain the algorithm's alignment with intended objectives. Risk link here is misalignment with business goals, inadvertent use of irrelevant data. The third principle, changes do not introduce bias and adhere to ethical standards. Risk links discrimination, ethical violations, and erosion of public trust. The fourth item, changes maintain or improve the ability to explain the algorithm's decisions and ensure clear accountability for changes. Risk links, opacity in decision-making processes, lack of responsibility for modifications. The fifth principle, changes follow secure development practices and maintain or enhance privacy protections. The risk link here, security breaches, unauthorized access, and privacy compromises. Principle 6, changes maintain adherence to laws and contractual obligations. The risk link here obviously is regulatory non-compliance or contractual non-compliance. So we now have an approach that is flexible and targeted. Embracing change, preserving integrity. With algorithmic systems, change is inevitable. We need to manage these changes in a way that preserves and enhances the integrity of our systems. Change must be deliberate, controlled, and aligned with our values and objectives. Systems vary in nature and complexity, etc., so the specific risks and controls will be different across systems. This means that a principles-based approach, underpinned by a risk assessment, will likely be better than a checklist approach. Ultimately, if you follow an approach like this, you will have better control, more effective, more efficient, a better use of your time and resources. That's the end of that article, bit of a long one. Thanks for listening.